Okay, thank you, Chloe. Hello. All right, so we're going to finish up topic 10.5 here, compressions and stretches of a function. And we've done probably over half of this already, so this hopefully will be a short class for you today. Heading into the weekend, that'd be nice. Okay. So again, a compression is when you multiply a function by a fraction, a number between 0 and 1, so like 0.5 or 3/4 or something like that. Okay. And a stretch for a graph is when you multiply the function by a number that is bigger than 1. So that stretches the function upward, makes it go up faster, or the compression, it doesn't go up as fast as it did originally. That's kind of where we were at with all this. Okay, so we can do a quick Desmos example just to refresh your memory here. Let's Desmos here. Okay, here's the Des. There we go. All right, so as you can see, we're doing exponentials in one of the other classes. All right, so let's just do an easy one. Let's do like an x squared. There we go. Oh, still not working. There we go. So there's an x squared graph. So again, if we put a decimal number in front of that, like 0.1, our graph goes flat, right? Let's go ahead and put x squared here as a reference too. So you see how it flattened out. Okay, and then if we take and put a bigger number in front of it, let's say 5. Notice that the graph in black is going up faster. So the graph in black would be a vertical stretch and be by a factor of 5, they would say. And then here we would have a vertical compression. Now the vertical compression could also be called a horizontal stretch. So picture grabbing the graph here in red and pulling it this way and pulling it this way. So like spreading out the red graph to become the purple graph. But most of the time we stick with saying it's a vertical compression. So it's like grabbing this graph and pushing it down. Okay. And then the stretch is grabbing this graph and pulling it up to this point here. Okay. So that's the basic idea of the compression and the stretch. All right. And then the other thing that we talked about last time was if you stick a negative sign in front of it, it flips the graph over and makes it an upside down U, like that. Okay. So again, a number between 0 and 1 gives you the wider graph in this case, because it's not going up as fast. A number bigger than 1 gives you a graph like this that's going up faster. And then if you happen to stick a negative sign in front of it, it flips the graph over. That's known as a reflection. Okay, so that's kind of where we were from last time. All right, so let's go ahead and check out a few. And I believe we left off about here. Okay, so it says, for each graph, identify the transformation applied to f that results in g and identify the value of k. So k means like move the graph up and down. Okay, and that was from the previous section. Remember that if you just tack a number onto a function, it moves you up and down. And if you put a number in with the x value, like in a parentheses, underneath a square root sign, inside an absolute value sign, then that moves you left and right, but it does the opposite of what you think. All right, so in this guy, here's our original here in blue. Okay. So that graph again would be an x squared graph, right? And then it starts at 2. That's up the right with here. So it starts at y equals 2. So this would be, so the f of x graph would be x squared and then plus 2. So the original graph would start at 0, 0, but with the plus 2, that moved us up 2 units this way. Okay? So then g of x, the first thing we notice, is very, very obvious, is that the graph is upside down now. So we do minus x squared. And then this one also starts at 2, so this will remain plus 2. So what we have here is a reflection around the line y equals 2, which would be the line going across here. That wasn't half bad, actually. So this is y equals 2 right here. So anytime you have y equals some number, that just means that we have a flat line going across at that number. Okay? Any questions? Not necessarily. Oops, hang on. Sorry about that, lost my mic for a second. So upside down is always a minus x squared, okay? But any function that you switch the sign on like that is going to flip the function around. It doesn't matter what kind of function it is. I just used x squared in our example because it's kind of an easy one to see. It's a little easier to see with that one than some of the other ones. That's all. But yeah, any graph where you stick a minus sign in front of it like that is going to flip it around. Okay? That's a good question, though. All right. So let's go ahead and check out another one here. All right, so it says identify the transformation. So it says and identify the value of k. So again, this is how much are we moving up and down. So as we saw last time, let's go ahead and break up the des again here. Get rid of these guys. So the basic square root function looks like this. So we do the square root of x. Get this out of the way. So there's our basic function. So again, nothing happens. Notice that the graph really pretty much starts right here at 0, 0. Okay. So nothing really happens for y as a negative number, or not y, excuse me, x as a negative number, because if you put minus 1 in for x, you'd have the square root of minus 1. And we know from trying to put that in our calculator, we get invalid input or syntax error or something like that. But it basically tells you, nope, can't do that. Okay. So since we can't take the square roots of negative numbers, this thing starts right here. Okay. So that's your basic look. And as you can see here, we're at 1, 1. If I can hit it, there we go, 1, 1. And then if we move over a little bit, when we go to 2, right, so not 2, excuse me, when we go to 4 and take the square root of 4, we get y equals 2. That guy right there. And if we go way out here, if we do 9, you take the square root of 9, square root of 9 is 3, so you get 9, 3. Okay? So the square root function will continue to go up, it just doesn't go up very fast. Okay? All right, so back to our regularly scheduled program. Drop him down, there we go. Okay, so this guy here, this is your basic setup here, because check it out. If this was sitting right here, this would be 1 and this would be 1. So this is going to be the square root of x. So f of x is the square root of x. And then see here we moved up 1, right? So then that would be plus 1. Okay? So that would be taking our Desmos graph and just putting a 1 on at the end here. Plus, whoops, too many pluses. 1. So there it is, starting at 1, 0. Same thing as we had on the other one. Okay. So then let's look at this guy. So notice here we went over 1 and up 1. Here we've gone over 2 and up 2. And we also started at 2. So the way we could write that is we would say g of x. So g of x equals 2 times the square root of x plus 1. Okay? And then what happens is if you multiply it out, so we do 2 times the square root of x, that's of course 2 times the square root of x. Oops. I don't know what happened there. Hang on. That 2 is kind of too big as well. All right, let's try it again. So that's going to give us 2 square root of x. And then if you multiply this guy, then you get plus 2. So g of x is going up twice as fast. As you can see here, it went over 1 and up 2, as opposed to over 1 and up 1. And then it also starts at 2 rather than 1. So it's going up twice as fast, and it starts at 2. Okay? So that's what we got going on there. Questions? Okay, thank you, Chloe. All right, let's go ahead and move on. So this says the graph of g is a reflection of f of x equals the square root of x across the x-axis with a vertical stretch of 3. So we have a vertical stretch with the factor of 3. It says write the function g. So if you take these step by step, these are pretty easy. Okay. So again, f of x was just the square root of x, right? So the first one says we have a reflection. So remember, reflection just means stick a negative sign in front, right? Then it says a vertical stretch of the graph by a factor of 3. So factor of 3, when you say factor, that means multiply. So we're going to multiply by 3. So that gives us our vertical stretch. And then the minus sign gives you the reflection. So this is your new function here, g of x. So that equals minus 3 times the square root of x. So that's our guy. And again, if we go to des here, so we'll get rid of the plus. So we'll do a negative for the reflection, right? So it reflected us down. See how it flipped over? And then if we put a 3 in here, that's going to make our graph go, actually, in this case, down faster. There we go. Okay. But see, it still maintains that same shape. I'll just back out a little bit. Okay. So again, the minus sign reflects us, and then the 3 stretched our graph out from the original. Questions? All right, let's check out a few more and we'll call it. All right. So this one says, what is the function rule for g of x, or just for g, I guess, such that the graph is a reflection across the x-axis of the graph of 2x plus 5 squared? Okay, so for this one, literally all we have to do, we don't necessarily need to multiply this guy out, but you could, but you don't have to. Okay, so all we really have to do is say g, sorry about that, let's change colors while we're at it. So g, not connecting today, of x would just be a minus in front of the 2x plus 5 squared. So let's take a look at Desmos here. So we've got a parenthesis, we've got 2x plus 5. That's an equals. Not good. There we go. Plus 5. Let's see on here. And then square it. That's not square. Not hitting the shift key fast enough. No. So there's our guy. And then notice that because this is squared, this just comes down and touches right here at minus 2.5. And the way you figure that out is you switch the sign on this guy, so it becomes minus 5, and you divide by 2. So minus 5 divided by 2 is negative 2.5. And at that point, this thing equals 0, and it goes up from there. So to do the reflection, all we have to do is put the negative sign in front of it. Like that. Okay? And like I said, you could multiply it out if you wanted to. You don't have to. If we multiplied this out, you would get 4x squared. Squared, there we go. And then it would be plus 20. And then plus 25. So notice that's the reflection of this now. So by putting the negative sign up front, what you do is you're going to switch the sign on everybody to get the same graph as we've got here in blue. So what we'd have to do for this guy is if you switch this sign, that's a good start, but that's not what we want, is it? So that means you have to switch the signs with all of them if you multiply it out. So I don't recommend you do that, but you can. Switch all the signs if you're going to do it like that. Now notice that it's exactly like this guy. And if I get rid of the sign here, the reflection. Okay, so that's just this guy multiplied out. And then by putting minuses in front of it all, or you can just leave it like this and put the minus out front and you're good to go. Okay. All right. So let's check out one more here. We'll call it. Okay, so it says, which function has a graph that is a vertical stretch of the graph f of x equals 4x squared minus 1? So which one is a vertical stretch? Okay, so if you put a 0.6 in front of it, that's not going to be a vertical stretch, is it? Because that would be in a compression, so it's not this guy. Okay? And then let's go ahead and see. So the next one up above it, we have a 6 in front. So that would be a vertical stretch, wouldn't it? Because we're multiplying by some number bigger than that. Now, it's going to have a different starting point, because what you would do is you would multiply the 6 by the 4. So this would be 24x squared. And then this one here. So you saw one like this previously where it stretched and it also moved up. Okay. So we're not looking for a reflection. We're just looking for a stretch. So this guy would be okay. This guy here would be a stretch, but it would start at -1, the same as this one does. Okay. So that's the difference between the two. Is here we're just multiplying 4 by the 6x squared, and then this was also stretched, wasn't it? And then this guy is a reflection. So this guy here would be an upside down. Okay. So this one's kind of a, C is kind of a double stretch, because we started this, made this number bigger, and then made this number bigger, but we had the same, the same starting point. Okay. All right, lady and gentlemen, that's all I've got for you for today. We'll go ahead and start a new topic next time, which will be next week. So again, appreciate you stopping by, and we'll see you then.